All right, so what we're going to do today, we're going to do tomorrow, which is completely reviewed tomorrow. Today's is it's going to be all brand new, and we're going to deal with just domain and range today. And domain and range, no matter what grade you're in, is a challenge for some students, okay? So I'm going to give you some pretty cool strategies today to be able to figure out domain and range from the equations. I think from pictures, much easier. You can look at the picture, you can see what's y max, y min, you can see if it's going to be all the x's, you can see if there's hole in the graphs. I mean, that stuff's easy. When it comes to the equation, and you do not have access to a graphing calculator, 431, you're going to have to use some new strategies. Okay? Now, when we talk about domain and range, right, domain is all the possible x values, range is all the y values. Now, we're just going to do one of them by sketching, okay, because, ooh, wrong, because if you can sketch it, it's pretty nice. Now, most of these you're not going to be able to say, oh yeah, I know what that looks like, but if you know what an absolute value x looks like, this is where we're going to start. And what we were going to do today is we're going to talk about transformations. So if you took 30 last semester, you've done transformations. If you take 30 this semester, we're on them right now. Okay? Now, if that's y equals absolute value x, okay, what is this negative going to do to this on the, okay, because that is y getting replaced with negative y. Remember, that negative belongs with the y, so that is a reflection on the x-axis. Okay, so that's the first thing we're going to do, because, and we're getting more to this in 30 probably today. You always do reflections and stretches first, translations last, and then this was 20-1 too. Okay, now what does this plus 2 say to do? 2 left. Okay, so 2 units left, and the minus 6, 6 down. Good. Okay, so if we take this, if we go 2 left, 1, 2, and we come down 6, 1, 2, 3, 4, 5, 6, we should be over here, and it should look like this, 2, negative 2, common negative 6. Now, by looking at this, what would you say the domain is? X in the reals. So let's do ours with interval notation. And range. How would you write that then? No. Negative infinity. Square bracket 6. Good. So I found that students are really good at, they look at a picture, they can tell me domain and range. In fact, that's how you learn these, is by doing just looking at pictures. Now, we're going to go in a totally different way, and we're going to do them algebraically. So here's all the things we're going to talk about. Okay, even powers, even roots, absolute values, rational expressions, and functions with constraints. We're going to get those all done today. And that's why I did not want to rush today, because it's all new. And if you have time to think about it and kind of process it a bit, then it's going to make sense. But if I got to power through it too much, you're just going to be writing notes down and go, okay, I'll try and figure this out later. Not that I have any idea what's going on, but okay. So the first thing we're going to talk about is even powers. Okay, for those people that don't know what an even power is, it is when you have an even power. 2, 4, 6, 8. Okay? Now, the trick is you want to isolate the power, and then even powers result in positive values greater than 0. This will make absolutely no sense to you right now, but as soon as we do one, it should. If the left-hand side of the equation must be greater or equal to 0, then so does the other side. Okay? So, this got squished here, I wonder. No idea how this all moved. Ooh, there we go. Okay, so if the left-hand side is greater than 0, then the right-hand side must be greater or equal to 0. Okay? So this will make more sense after we do this one question. Okay? Now this one says, find the domain of x minus y squared equals 8. Okay? So the steps, number 1, if you look up at number 1, it says isolate the even power. So this will be negative y squared equals 8 minus x. And the next thing I'm going to do is I'm going to divide the negative 1 out. So that is going to be y squared equals x minus 8. Now, what do we know about the left-hand side? The left-hand side is positive, right? So we know that the left-hand side has to be greater or equal to 0. Therefore, we can say that the right-hand side must be greater or equal to 0 because these two sides equal each other. You know why I know that? That equal sign thing in between the two. Okay? So if it's saying, hey, x minus 8 has to equal something greater than 0, that means x minus 8 is greater than 0. So then all we have to do is go x minus 8 is greater or equal to 0. And then we solve for x. So we'll add 8. X has to be greater or equal to 8. So therefore the domain would be square bracket 8 comma infinity. Okay, and if you kind of remember from 30, or some of you from yesterday, that if you had y squared, right, this would be y equals the square root of, or plus or minus, the square root of x minus 8, right? Well, we do know that this is the square root graph, right? Now this one, it wants us to do plus and minus, right? And then what does the x minus 8 say? Move it to the right 8. So you can see the domain of that would be 8 comma infinity. Okay? Yep. Yeah, and you know the y's could be in the reals because anything can go in here. Yep. So sometimes the pictures help. Well, I think a lot of times the pictures help, but can you come up with them? So obviously the more, I mean, that's the goal of 30-1 is can you see the algebra and the graph, can you always see them at the same time? If you know how to do that very well, calculus is a lot easier. Okay, so find the domain and range of this one algebraically. Okay, now doesn't matter which one we do first, but if we isolate the x squared, then we'll be going and finding the range. If you're isolating the y squared, okay, and you'll see that as we do these. So let's just isolate this first, okay? So this would be 4x squared equals negative 16 minus y squared. Sorry, plus y squared. Okay, now divide by 4. Actually, even this one we don't have to, but see, I try to keep these as simple as possible. I can leave it like that because what can I say right now? The left-hand side must be greater or equal to 0, right? If you divide by 4, you will make your life harder because you're going to have to deal with fractions. But if you did, you're still going to be able to get the right answer. So if the left-hand side is greater, therefore the right-hand side must be greater or equal to 0 as well. So then I would just go negative 16 plus y squared has to be greater or equal to 0. Okay? So you can see that when you isolate the x squared, you're going to find the range because you're just left with a y. Y will give you the range, right? So now this one here, so yeah, if we go y, oops, that's greater or equal to 0, y squared has to be greater or equal to 16. Okay? Now, what can go in there? Right? Because if we take the square root of both sides, y, it's got to be greater or equal to plus or minus 4. Okay? So, what would be, this is range, so the range would be, oh, no, we shouldn't have done that because this gets confusing. That's not true, actually. If we back this up, right, we should stay here and just think about it because it's a bad thing. When you ever have an inequality and do that, we would say that y has to be greater or equal to 4 and y would have to be less or equal to negative 4, right? So the range would be negative infinity, comma, oops, that's a horrible negative infinity, comma, negative 4, and 4, comma, infinity. Well, remember when we're ever dealing with an inequality and you're at this, okay, remember how if you just take the square root of both sides, you're going to leave it like this. You're going to say, oh, so y is greater or equal to plus or minus 4. If y is greater than negative 4, the answer to that would be like negative 3, right? That's a good test. Is negative 3 squared bigger than 16? No. So when you're ever at y squared equals a number or x squared equals a number, stop there and it'll always be this, okay? And that just comes from experience of knowing not to do a square root when you have that inequality there. If there was an equality, then yeah, just square root, you get plus or minus. It's equal, doesn't matter, right? Okay, so now we'll do domain of this. Now if we're going to do domain, let's get the y squared by itself. So that's negative y squared equals negative 16 minus 4x squared. Divide by that negative, you get y squared equals 16 plus 4x squared. Okay, so the left-hand side has to be greater or equal to 0. Therefore, right-hand side has to be greater or equal to 0. So 16 plus 4x squared is greater or equal to 0. Okay, I'm going to bring the 16 on the other side. 4x squared is greater or equal to negative 16. Divide by 4. X squared has to be greater or equal to negative 4. Okay, now this is we got to think at this stage instead of keeping on going with the algebra. What side, this left-hand side will always be positive, right? Okay, so is there anything in there that's bad? Wouldn't every x work? Okay, so when we see something like this, we would say that the domain would be negative infinity, comma infinity. Okay, so a little different than we've done before, but it's just isolating, saying, okay, if that is greater than 0, then that must be greater than 0, and then doing the algebra from it. Okay, now even roots, so 2, 4, 6, right? Now even roots, you want to isolate the radical. Then the radicand, the inside of the root must be positive or 0, right? So therefore, when you've isolated the side, it's very, very similar to when you isolate an x squared. Every radical has to be greater or equal to 0. The radical outside the root must be positive or greater than 0. Okay? So to do this one, I will go root 3y plus 1 equals 10 minus 2x. Oops. Okay, and then I have to divide by negative 1. So 3y plus 1 equals negative 10 plus 2x. Okay, so very similar to the last one, the left-hand side has to be greater than 0. That answer will be greater than 0. Therefore, the right-hand side must be greater or equal to 0. Okay, so then you just have to go, I'm going to switch this to 2x minus 10. Has to be greater or equal to 0. Add 10 to both sides. 2x has to be greater or equal to 10. Then divide by 2. X is greater or equal to 5. Now, for this one, the range would be, we would just look at what we've always looked at, and that is that we know this has to be greater or equal to 0. So for range, 3y plus 1 has to be greater or equal to 0. Subtract your 1, 3y has to be greater or equal to negative 1. Divide by 3, y has to be greater or equal to negative 1/3. Okay, so I forgot to put the domain x greater than 5 would be square bracket 5 with infinity round bracket. Range would be greater or equal to negative 1/3. So I got negative 1/3, comma, infinity. How's that? Okay, so it's not hard stuff, but it's totally different than probably you're used to. Okay, so I've decided, do we need to do another one? This one's very similar to the last one, so I think we're good. This one just has the x changed with the y. Don't think it's a very different example. Yeah. Let's go on to absolute values. So now absolute values, as we've already dealt with, right, they are a little bit of a challenge to do algebraically because of the when it's greater than 0, and when the stuff inside the absolute value signs is not greater than 0, we're going to multiply by a negative, okay? So the method, very similar to the other two, we're going to isolate the absolute value. Then the argument inside the absolute value can be all real numbers, okay? Usually there's nothing bad inside absolute value. Now that's not always true, because it could be 1, absolute value 1 over x plus 12, where x can't be 0 in that case, okay? But if it's up top, there's not going to be too many limitations, and the absolute value itself is always positive or 0, okay? So when we're dealing with this one, let's just isolate. So we'll go 4y minus 15 minus 9 equals absolute value 6x plus 12. Okay, and that's just going to be 4y minus 24 equals. Okay, now if you look, first of all, we kind of, these are in some ways nicer because you can always look right there and go, first of all, our domain is negative infinity and infinity. Nothing's going to go wrong there. Okay, now when we're looking for range right now, we know that since the right-hand side is greater or equal to 0, the left-hand side has to be greater or equal to 0. Okay? So then we'll just write that statement down. 4y minus 24 has to be greater or equal to 0. Okay? 4y has to be greater or equal to 24. Divide by 4, y has to be greater or equal to 6. So the range, greater or equal to 6, gets to include it. So we use a square bracket, comma, infinity. Okay. Good. Okay, example 2 is pretty similar. We don't need to do example 2. Okay, next, rational expressions. Now, we always want to first isolate the rational expression. The denominator cannot equal 0, since it makes the fraction undefined, and the fraction cannot equal 0 if there's no variable in the numerator on the top. Okay, so let me show you what that means. So we're going to deal with this one. We will first, I don't know how these all got out of whack. Guess it doesn't matter. We can adapt. Okay, so let's get negative 11 out of there. Okay, so if we do that, we will get 4x. That's going to be a positive 11 plus 12 equals 8 over y minus 5. Okay, now, the first thing that we can just talk about is that, let's do the range first. That one's easier. We know that y minus 5 cannot equal 0. Therefore, y cannot equal 5. Okay, so how do we write y cannot equal 5? The range would be everything but 5. So we put round brackets. Oh, yes, I do. Okay, now, what is the only thing this cannot equal? 0. Okay, so we can say that when does 4x plus 12 not, or it can't equal 0, okay? So we can, again, if the right-hand side cannot equal 0. Therefore, the left-hand side cannot equal 0 then. They have to follow the same rules. Okay, so 4x cannot equal negative 12 divided by 4. X cannot equal negative 3. Okay, so domain, very similar to range. Negative infinity, comma, negative 3. Round bracket union, negative 3, comma, infinity. Okay. How's this? Okay. So one more, or no, we're going to do one more. Functions with constraints, okay? So these are the ones I was talking about actually that are a bit more work. So isolate the variable with constraints, and the other side of the equation must obey the constraint as well. So what does this mean? Okay, here's an example. 4x minus 3y equals 7. And y has to be greater or equal to negative 1 and less than or less than 4. Now, what would be really nice is if we could put this inside here. And we can't because it says this is what y represents, so why don't I get this to be what y represents? So we just make it y equals. Okay, so that would be negative 3y equals 7 minus 4x divided by negative 3. So y would equal, I'm just going to, that'd be 4/3 x minus 7/3. Okay, so now all you have to do is go like this. Negative 1 is less than or equal to 4/3 x minus 7/3. Less than 4. Because I took y and replaced it with y. So all you're dealing with is two equations. Okay, so you're going to be going like this. So the first one we're going to do is when 4 over 3x minus 7/3 is greater or equal to negative 1. And the other one will be when 4/3 x minus 7 is less than 4. Thank you. Okay, so if we're going to find our domain, the best thing we want to do is get x by itself. So let's add 7/3 to both sides. I'm just doing the left one right now. Yep, you can do that. So if we multiply everything by 3, okay, that would give me, so if I multiply this all by 3, 4x minus 7 is greater or equal to negative 3. For x will be greater or equal to, that's coming over to be positive 7, so that's 4. Divided by 4, x is greater or equal to 1. Okay. Because we've been given restraints for the y's, we'll also have the same setup for the x's, so we've got to solve the other side. Again, if we multiply everybody by 3, we will get 4x minus 7 is less than 12. 4x is going to be less than 19. X has to be less than 19 over 4. So we have to be greater than 1 and less than 19 over 4. So the domain would be greater or equal to 1 and less than 19 over 4 with a round bracket, right? Because okay, so I'm not going to do the second example on this one either. So the homework is 1A, C, E, G, and I.